Hi everyone, welcome to lecture 16 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will study chemical equations, how to balance chemical equations. A chemical equation gives us a lot of information. A chemical equation gives us information about the reactants and the products. This is a chemical equation. This side is the reactant side, and this side is the product side. So it gives us information about the type of reactants that we have and also the type of products that are formed. Also, it shows us how atoms, molecules, or ions rearrange to produce other substances. For instance, in this equation, it shows us that when PCl5 reacts with water, it will form POCl3 plus HCl. So it shows us how these reactants react and how they have rearranged to form other new substances. Also, a chemical equation tells us whether the reactant or product is a solid, liquid, or gas, or whether it is aqueous. So in this equation, S means that PCl5 is solid, L means that water is liquid, L means that POCl3 is liquid. So it also tells us whether the reactant or product is solid, liquid, or gas. And also, it tells us the number of atoms that are reacting. So for instance, it shows us here that there are 5 chlorine atoms and that there are 2 hydrogen atoms. And on the product side, it shows us that there are 3 chlorine atoms here. So a chemical equation gives us a lot of information, and it also tells us the number of molecules that are reacting and number of molecules that are formed. For instance, the number of molecules here is 1. The number here is 1 because there is no number written, but the number of molecules here is 2 because 2 is written there. So chemical equation also gives us the mole ratios of reactants and products. We already know that the reactants are on the left-hand side, these ones, and the products are on the right-hand side. So the mole ratio of oxygen to ammonia is 5:4 because there are 5 molecules of oxygen and 4 molecules of ammonia. So in this equation, 5 moles of oxygen can react with 4 moles of ammonia to give 4 moles of NO plus 6 moles of water. So a chemical equation can give us a whole lot of information. So this is also known as stoichiometry of a reaction. So stoichiometry gives us the quantities of materials that are used in a chemical reaction. As we have seen here, 4 moles of ammonia reacts with 5 moles of oxygen to form 4 moles of NO plus 6 moles of water. So now we look at balancing of chemical equations. So this is an example of a chemical equation that is not balanced. The reason why it is not balanced is because the number of atoms on the left-hand side is not equal to the number of atoms on the right-hand side. So we have 2 hydrogen atoms here, 2 hydrogen atoms here, but we have 1 here and 2 here. So this is an example of an unbalanced chemical equation. For us to balance any chemical equation, there are three rules that we must follow. The first is to balance the metal first. The second is to balance non-metals except hydrogen and oxygen. And then the last thing to do is to balance hydrogen and oxygen last. Right. So let's have a look on how to apply these three rules. So if you're asked to balance this chemical equation, the first thing you do is to balance the metal first. But because there is no metal here, we go to the second rule. So which is to balance the non-metals except hydrogen and oxygen. But because we only have hydrogen and oxygens, we then start from hydrogen. So how many hydrogens do we have on the left-hand side? It is 2. And how many hydrogens do we have on the right-hand side? It is also 2. So at this point, it is balanced. The next one then is oxygen. How many oxygen do we have on the left-hand side? It is 1. And on the right-hand side, it is 2. So oxygen is not balanced. So how do we balance oxygen? The only way we can balance oxygen is if we put 2 as a coefficient here. If we put 2 here, we will have 4 hydrogen atoms because 2 multiplied by 2 will then be 4. So then we cancel these 2 because we have already added 2 here. And if we put 2 here, we also have 2 oxygen atoms. And then we cancel this one because we have already added 2. And if we come to the right-hand side, if we put 2 here, we will have 4 hydrogen atoms, and it will then be balanced with hydrogen on the left-hand side. And here, oxygen is 2. It is also balanced with the oxygen on the left-hand side. So in this way, we have 4, 2, and then 4, 2. So the equation is balanced. The balanced equation is then 2 molecules of water gives 2H2 plus 1 molecule of oxygen. Right, so if you're asked to balance this chemical equation, you simply follow the same rules. So the first thing is to balance the metals, but there is no metal in this equation, so we go to the next rule, which is to balance the non-metals, except hydrogen and oxygen. That non-metal is nitrogen. So how many nitrogens do we have on the left-hand side? It is 1, and on the right-hand side, we have 2 nitrogen atoms. So nitrogen is not balanced. So how do we balance nitrogen? If we add 2 here, then nitrogen will be balanced. So we then have 2 nitrogen atoms on the left-hand side and 2 on the right-hand side. So nitrogen is then balanced. The last thing is to balance oxygen. How many oxygens do we have on the left-hand side? It is 4. 2 multiplied by 2, 4. And how many oxygens on the right-hand side? It is only 2. So we need to balance oxygen. And again, the only way to balance oxygen is if we add 2 here. So if we add 2 here, we will have 2 multiplied by 2, 4 oxygen atoms. So we cancel these 2 because we already added 2 to make oxygen balanced. So we'll have 4 oxygen atoms on the right-hand side and 4 oxygen atoms on the left-hand side. And we also cancelled 1 for nitrogen because we added 2 to make nitrogen balanced. So then the balanced chemical equation will be 2NO2 gives 1 molecule of nitrogen gas plus 2 molecules of oxygen. So let's have a look at another example. If we are asked to balance this chemical equation, we follow the same rules. So we first of all balance the metal. So the metal here is chromium. So how many chromium do we have on the left-hand side? It is 2. On the right-hand side, we also have 2. So chromium is balanced. The next thing then is to balance the non-metal except hydrogen and oxygen. So the non-metal here is nitrogen. So how many nitrogens do we have here? We have 2 here. So n equal to 2 here. And how many do we have here? It's also 2. So the metal and non-metals are both balanced. So the next thing now is to balance hydrogen and oxygen. So how many hydrogens do we have here? We have 2 multiplied by 4 is 8. And here, how many hydrogens do we have? We have only 2. So hydrogen is not balanced. So how do we balance hydrogen? If we add 4 here, we will have 4 times 2 will be 8. And hydrogen will be balanced. So then we cancel these 2 because we already added 4 here. So hydrogen will then be 8. And then it is balanced with hydrogen on the left hand side. So the next and the last one then is oxygen. How many oxygens do we have here? 7. But here we will have 3 here. Because we have already added 4 here, it will then be 7. So oxygen is also balanced. So then the balanced equation is this. So this is how to balance chemical equation. You balance first the metal, then you go to the non-metal, then you balance hydrogen and oxygen last. So if you're asked to balance this equation, we follow the same rules. So we balance first the metal, followed by the non-metal, except hydrogen and oxygen, and we balance hydrogen and oxygen last. So sodium is the metal, so sodium here, the number of sodium on the left-hand side of the equation is 1, and number of sodium here on the right-hand side is 2. So how do we balance sodium? Because it's 2 on the right hand side and 1 on the left hand side. So the only way to balance it is to add 2 in front of sodium. So if we add 2 here, we will have 2 sodium atoms on the left hand side, and we will also have 2 on the right hand side. So the next thing then is to balance the non-metal except hydrogen and oxygen. So we do hydrogen and oxygen last. And the non-metal here is sulfur. How many sulfur do we have here? We only have 1 sulfur here on the left-hand side. And how many sulfur do we have on the right-hand side? Is also 1. So sulfur is balanced. So the next thing then we do, which is the last thing, is to balance hydrogen and oxygen. So hydrogen on this left hand side, we count it. Remember, we have added 2 here, so it will be 2 plus 2, it will be 4. So we have 4 hydrogen. And then for the oxygen, we have added 2 already here, so it will be 2 plus 4, it will be 6. And on this right hand side, we have how many oxygen? We have 4 plus 1, 5. And how many hydrogen? We have 2. So we have 2 hydrogen here, 4 hydrogen here. So we need to balance it. So the only way to make this hydrogen 4 is if we add 2 in front of water. So if we add 2 here, we'll have 4 hydrogen, and we cancel these 2 because we have added 2 already. So we'll have 4 hydrogen, and it will balance with the left hand side. And also for the oxygen, it will also be balanced because then we'll have 4 plus 2, which is 6. So in this way, the equation is balanced. So the ones that I have cancelled are the ones that we are no longer using. So in this way, we'll have 2, 1, 4, 6, and here we have 2, 1, 4, 6, which is then balanced. So the balanced equation is 2NaOH plus H2SO4 to give Na2SO4 plus 2 molecules of water. Right, if you are asked to balance this equation, you apply the 3 rules. So the first thing we do is to balance the metal first. So the metal here is aluminium. On the left hand side, we have 1 aluminium, And on the right hand side, we have 2 aluminum. So aluminum is not balanced on both sides of the equation. So the only way for us to balance aluminum is to add 2 here. So if we add 2 here, aluminum will be 2 on the left hand side and it will be 2 on the right hand side. So then aluminum is balanced. The next thing is to balance the non-metals apart from hydrogen and oxygen. So that non-metal is sulfur. On the left hand side, sulfur is 1, but on the right hand side, sulfur is 3. We have 3 sulfur atoms on the right hand side. So we need to balance sulfur. So the only way for us to balance sulfur is to add 3 here. So if we add 3 here, we will then have 3 sulfur atoms on the left hand side, and we will also have 3 sulfur atoms on the right hand side. So we then cancel 1 because we have added 3 already. And for aluminium, we also cancel 1 because we have added 2 already for aluminium as a coefficient. So then in this way, aluminium and sulfur are both balanced. The next thing then is to balance hydrogen and oxygen. So how many hydrogens do we have on the left hand side? We have 6. And on the right hand side, we have only 2. So hydrogen is not balanced. So how do we balance hydrogen? If we add 3 here, we will have 6 hydrogen atoms. And in that way, hydrogen will be balanced on both sides of the equation. So we cancel 2 because we have already added 3 here, and 3 multiplied by 2 is 6. So we cancel these 2. So then the last thing is to balance oxygen. How many oxygen do we have on the left hand side? It is 12 because we have 3 multiplied by 4 will give us 12. And on the right hand side, how many oxygen do we have? Is also 12. 4 multiplied by 3 is 12. So in this way, all the atoms are balanced because we have 3 sulfur, 2 aluminium, 6 hydrogen, 12 oxygen. And the same thing is applicable on the right hand side. So 3, 6, 12, 3, 6, 12. And then we have 2 aluminium, 2 aluminium. So then the balanced equation is 2 aluminium plus 3H2SO4 to give L2SO4 bracket 3 plus 3 molecules of hydrogen. Okay, so just to test your understanding, you can practice these ones here, and then you see whether you get the answers correct. And I have the answers on the next slide, but it will be advisable for you to practice balancing them first before looking at the answers. So these are the answers to the problems in the previous slide. Okay, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.